Right up here, we have a question that I want you guys to look at. So if you guys notice on the smartboard up here, you have a picture of Jupiter versus what? What's the other thing that we have here?
Oh, it's Earth.
It's Earth up there. So I was shocked, you guys, when I saw this picture because the Earth versus Jupiter, what do you guys notice about the sizes? Ryan?
Jupiter's a lot bigger than Earth.
Jupiter's a lot bigger than Earth. Awesome. The objective of my lesson was to have the students work on comparing numbers in scientific notation, being able to apply the knowledge that they learned to add, subtract, multiply, divide numbers in scientific notation, and use their skills to apply it to word problems where they had to compare different numbers in scientific notation. And then it says the circumference of Jupiter is 4.5 times 10 to the 5th kilometers. How many moon circumferences do you need to be able to stretch across the circumference of Jupiter? The skill set that the students are asked to learn in this class and to practice in this class will be really helpful for them when they're in high school, in college, especially when they're in the science classroom. They're asked to compare different numbers, be able to get an idea of number sense and understanding what different numbers represent, especially when they're working in their labs and their application classes and application problems.
So we would divide 4.5 by 1.1. So just put that on the side over here. 4.5. Okay. We have to turn them to regular numbers. So it'll be 45 divided by 11.
Let's go back to this up here. Let's do this together. So the students were asked to make sense of the problems. The first time they were asked to was when we did our initial problem together as a whole group, and we got the answer of 41, and I asked the students, what is 41? So they had to discuss with their partners what 41 is and what it means in this specific problem, and whether or not it made sense. So first of all, the students had to understand 41 what. So once they figured out they needed 41 circumferences of the moon to compare to the whole circumference of Jupiter, then they were asked, does this make sense? Does it seem right that you would have 41 moons to cover the circumference of Jupiter?
First thing you probably have to do is do 4.5 divided by 1.1. Be 45 divided by 11 though, so you have to move the decimals.
Move the decimal over for both of them, so 45 11.
It goes in 4 times, right, for 44?
1 and then 0.0 and bring down the 0 and then
0, and just 0.0, and then bring down one more 0.
yeah.
So you can put 11 into 100 9 times,
Yeah.
or 99.
Yeah. And then 9
And that'd be
9
that
1.
would just repeat.
Yeah, it'd just be
Going
repeated.
0909.
Yeah. 4.09.
And then for the exponents, you'd have to subtract 5 minus 4.
division, so you'd have to subtract. Okay, so
5 minus 4 is just
5
1.
is
So that'd just
So-
be 10 then.
oh yeah. So 4.09
Times 10.
times 10. Yeah.
You simplify that though, if you actually multiply 4.09 times 10, it'd be 40.9.
The next step is to have the students be able to apply their knowledge to any problem that they created. That way they can really show that they really understand what it is that they're doing, because sometimes the kids will just solve the problems and not necessarily follow or understand what they're doing. But if they're creating their own, they really are able to demonstrate their understanding of comparison of numbers and operations with scientific notation. You always have to ask yourselves, does my answer make sense? So discuss with your partners, what does this answer even mean? And does this answer make sense? So talk to each other, what does this mean? And does it seem like an appropriate answer? Go. What numbers are you dividing?
5 and 7.
5 divided by 7. So how are you going to divide that out?
There's going to be like a decimal.
That's absolutely right. But right now you're doing 7 divided by 5.
Oh, so you move the decimal.
Oh, so you have 5 inside?
So it's
Alright.
7 divided by 50.
Exactly. You figure out how many times. Well, no, you don't need to adjust it. You just, where does the decimal place go? I have a question for you. 5 divided by 7, is that going to be greater than 1 or less than 1?
Less.
Right. So where would your decimal place go in your answer?
Here?
Right. Perfect.
So it'll be 37.5 times 10 to the negative 4th times 10 to the 4th.
Negative 4th? Yeah.
If you're doing -4 plus 4, though, it cancels out.
Cancels out.
So it's just...
It'd be 0, right?
No, it would be 37.5 times 1, wouldn't it?
Yeah. Because, yeah. Where did we go around here?
37.
37.5.
Perseverance has been a major theme. They're starting to get it. They're getting the idea that they really have to work hard at it. They're so used to the questions that I ask them. I'm constantly asking them, is it okay if you get it wrong? Yes, it's okay if you get it wrong. What do you have to make sure you do? You have to try. You have to learn from your mistakes. What does 41 mean? 41 what?
41. Jupiter is 41 times as bigger than the Earth.
Yeah, then the what?
The Earth. The moon.
Than the moon. Very good. So it's 41 times bigger than the moon. Does that make sense? Does that seem like an appropriate answer?
Yeah.
Yeah? Why? Why does it seem like an appropriate answer? When they were done working on problems, I asked them to label their units. And there was one time where the answer was 37.5 inches, and there were some kids who said 37.5 years, which meant that they just went through and they solved the problem and they didn't really understand what they were doing.
What's 7.5 times 5?
Do you have to line up the decimals?
Yeah. Or no, you don't.
That was multiplication.
No? Okay.
It's just 7.5 times 5 and it's at the end? Yeah, and then you move the decimal over
Yeah, it
one
would be
place.
37.50. But then it becomes 1, so it would just be, the final answer would be 37.50. Because it becomes the 10 to the 4th, and 10 to the -4th cancel each other out, so it would be 10 to the 0th power, which is 1. And then any number times 1 is itself.
Right, if you have 37.5 times 10 to the 0th power,
No,
37
yeah, that's 1.
37 is still too big, so you have to make the
Yeah.
exponent bigger.
3.7. Do you want us to round to like...
No, you can, because 37.5 is not a repeating decimal, you can just leave it that way, right?
Wait, so we could just leave it as 37.50? Or do we have
Multiplied by 10 to the what power?
0th power,
and
which
I
would be 1.
Right, very
So
good.
it stays the same, but then you have to make it smaller.
So, yes, exactly.
So it become 10 to the first power. Yeah.
So it would be 3.7.
Label your unit, 3.75 times 10 to the first power, what?
Years.
Inch per year.
Or inch per year.
Okay, so I want you to make sure you're really getting what the problem is saying, right? So it's telling you how fast it's growing per year, and it tells you how many years are going to pass by. So what are you trying to figure out? Read the problem again.
How much it will move per year?
Well, you know how much it increases per year, don't you?
Yeah.
Right? It says, at this rate, what is the length of a stalactite that grows for 7.5 multiplied by 10 to the 4th years? Right? So what are you trying to figure out, you guys?
The length.
The length.
What ends up?
So it's 3.75 times 10 to the first power, what?
Inches.
Inches, right? Isn't that how you would measure the length in this problem?
Yeah.
Excellent, very good. So having the students constantly think about their answer. What does it mean? What is the unit? How does it apply to this problem? Does it make sense? Is something really important, especially with these real world applications.